particle P moves along a straight line. So it's moving along a straight line. Initially, P is at rest at a point O. So T equals 0, V equals 0. Yeah, so at T equals 0, V equals 0, X equals 0. On the line, at time t seconds, the velocity of P is V, where V equals, so V is equals a function of T, therefore it's not SUVAT. It's not a constant acceleration question. Find the values of T and the corresponding values of V when the acceleration is instantaneously 0. So the question is asking you, when is the acceleration 0? So at the moment we've got V is equal to 1 over 20t times 5 minus t all squared. Okay, so we should know, if I want the acceleration, we've got displacement, velocity, acceleration. When we're moving in this direction, we differentiate with respect to t, and that direction we integrate with respect to t. So here we go from velocity to acceleration, so we've got to differentiate. So we get dv dt is equal to the acceleration. But before we do that, because we're going to differentiate it, we need to get it into a polynomial form. So the language I've used is kx to the n form. Going to differentiate, going to differentiate with respect to t, therefore get in polynomial form. In other words, expand out the brackets. So V is equal to 1/20th of t times 5 minus t squared is 25 minus 10t plus t squared. You can use a grid if you need to for that. Now expand, so we get 5 over 4t, that's 25 over 20, gives 5 over 4t, minus a half, 10 over 20 is a half, t squared, plus t cubed over 20. Now I've got it in that standard polynomial form, I can differentiate it. So dv dt, which is equal to the acceleration, equals 5 over 4 minus t. If I go through the working properly, write down the constant, bring down the power, subtract 1 from the power, plus write down the constant, 1/20th, bring down the power, subtract 1 from the power. Then tidy it up, 5 over 4 minus t plus 3/20th of t squared. Okay, now what are we asked? Let's check. Find the values of t and the corresponding values of when the acceleration of p is instantaneously 0. So we want a equal to 0. When a equals 0, 0 equals 5 over 4 minus t plus 3 over 20 t squared. Well, I think the best thing to do here is multiply through by 20, and we'll get 0 equals 25 minus 20t plus 3t squared. That looks like it might factorise. Let's try the grid. If it doesn't, we'll have to use the equation. 3t squared plus 25. Numbers that multiply to give 3 times 25, which is 75, and add to give minus 20. How about something like 15 and 5? They multiply to give 75, and they will add to give minus 20. So minus 15t minus 5t factorised 3t, t minus 5 minus 5. So naught is equal to t minus 5 and 3t minus 5. So t equals 5 or t equals 5 over 3. So what have we asked for? The final values of t and the corresponding acceleration of p is instantaneously at 0. So at t equal 5, that's nice and easy to substitute back in. I would go back to the original equation, because when t equals 5, the bracket here is going to be 0, isn't it? So we've got v equals 1/20th of t, which is 5, and 5 minus 5 squared, well, that's clearly 0 meters per second. And the second one, when t equals 5 over 3, v equals 1/20th of 5 over 3 times 5 minus 5 over 3 squared. So we get 1/20th, so that's 1/12th, tidying that up, times 15 minus 5 is 10 over 3 squared, so we get 100 over 9 times 12 is 108. So that is 50 over 25 over 27 meters per second. You could tap it in the calculator and it'll come out to be around 0.9, 0.92, something like that.